Hi guys, video for you on rules for assigning oxidation numbers. Number one, free elements oxidation number is 0. Free elements are unbonded elements, so for example that could be sodium and iron. When they exist, when they exist on their own, they are going to be free elements and the oxidation number is 0. Rule number two, the sum of oxidation numbers in a molecule is equals 0. So again, I'll just give you the example of water, H2O. You've got two hydrogens there, one oxygen. Whatever number we assign to those, when we add them all, it should all equal 0. So later on in the rules, you'll understand why I'm using these numbers, but hydrogen I know is going to be +1. That's in rule number 5. So both hydrogens are going to be +1, and in number 6 it's telling me oxygen is going to be -2. When I add all of those up, I do get 0, so that is correct. Rule number 3, the oxidation number of a simple ion is the charge on that ion. Simple ion, for example, the chloride ion, it's equal to the charge on that ion, so the charge is -1, so the oxidation number is going to be equal to -1. Another one, Fe3+, the charge is 3+, so the oxidation number is going to be +3. Next, we've got the sum of the oxidation numbers in a complex ion are equal to the charge on that ion. So if we take an example of a complex ion, like we've got the nitrate ion, NO3-, when you add up the nitrogen and the 3 oxygens, whatever number you give those, when you add them all up, it should equal to -1. So for our molecules, there's no charge on a molecule. The water we looked at a while ago, there's no charge up here. So that rule 2 is that on a molecule it equals 0. For our complex ion, an ion is something that has a charge. We've got a charge here on the nitrate of -1. So when we add up the oxidation numbers of everything, all the atoms in the ion, that must equal to the charge on the ion. Rule number 5, we touched on briefly a while ago, that hydrogen has an oxidation number of +1. So if we look at examples like H2O, each hydrogen there is going to be +1. H2SO4, sulfuric acid, each hydrogen there is going to be +1. HCl, each hydrogen there is going to be +1. The exception to this is when we've got a metal hydride. And a metal hydride is a hydrogen bonded to a metal in group 1 or a metal in group 2. So for example, that would be if we had sodium hydride, NaH, their hydrogen would be -1. In group 2, if we had MgH2, there, each of those hydrogens is going to be a -1 as well. Rule number 6 is that oxygen is always going to be -2, with some exceptions as well. So in H2O, if we look at that, H2O, oxygen there is going to be -2. H2SO4, another one we looked at a while ago, oxygen is going to be -2. The exceptions here are in peroxides. A peroxide, for example, hydrogen peroxide. Here we have to look at rule number 2 again, and that states that the oxidation numbers must add up to give 0. And looking at rule number 5, we know that each hydrogen here must be +1. So whatever we give to our oxygens, they have to all add up to give 0. So that must mean that our exception here is in peroxides, our oxygen is going to be -1 instead of -2. The other exception here, if we look at 6 exception part 2, is that when oxygen is bonded to fluorine. Fluorine is the most electronegative element. So when anything is bonded to fluorine, fluorine has its own rule. Fluorine is always going to be -1. That's a rule there in number 9. The halogens are always -1. So fluorine is going to be -1, and in that case, to balance that out, to satisfy rule number 2, for that to equal 0, oxygen there is going to have to be +2. So those are your 2 exceptions. Rule number 7, the alkali metals, these don't require much explanation. Rule number 7 is that anything in group 1, so sodium, lithium, potassium, they're always +1. So group 1 in our charges, we know group 1 always has a +1 ion, and same for oxidation number, it will always be an oxidation number of +1. Rule 8 is the same for group 2, magnesium, calcium, they're always going to have an oxidation number of +2, similar to the rule for their charges. And last but not least, rule number 9 is about the halogens, so group 7. When you've got a halogen, so when you've got fluorine, chlorine, iodine, bromine, when they're in a compound, they're always going to be -1. Again, of course, there's another exception to a very important rule, is that it's except when they're bonded to something more electronegative. So that should say when bonded to a more electronegative element, it should say down here. When bonded to a more electronegative element. For example, chlorine that we see here should always be -1, except if it's bonded to something like oxygen. Oxygen is more electronegative, so oxygen takes precedence here. We follow rule number 6. Oxygen is going to be -2, it's more electronegative, and that must mean in order to satisfy rule number 2, to make sure that the molecule adds up to 0, chlorine, the 2 chlorines in there must be +1. Another example of that is if you had iodine and fluorine bonded together. Fluorine is more electronegative, so fluorine would be -1, and that would mean that the iodine here is going to have to be +1 in order to satisfy rule number 2. That's it for the rules. Hope this was helpful for you. Any questions, do send me a message and let me know.